Using MCP, I injected Conway's Game of Life directly into Minecraft source code. Doing this wasn't easy and required me to work around a lot of Minecraft's built-in systems. Today, I'm going to show you how to do it. For those of you who aren't familiar, Conway's Game of Life is a zero-player game that simulates the life and death of cells on a grid, perfect for Minecraft. You don't control anything directly. Instead, you set up an initial pattern, then sit back as it evolves over time based on just 4 simple rules. Despite how simple those rules are, they can lead to incredibly complex and unexpected behavior. Let's take a look at how it works. To be able to implement Conways into Minecraft, we're going to first have to understand the rules of Conway's Game of Life. Rule 1 states that any living cell with less than 2 neighbors dies of underpopulation. Rule 2 states that any live cell with 2 or 3 neighbors survives. Rule 3 states that any live cell with more than 3 neighbors dies from overpopulation. Rule 4 states that any dead cell with exactly 3 neighbors becomes alive. This is known as reproduction. Using these 4 simple rules, we can create patterns like this glider that traverse across the grid entirely on their own. Now back to Minecraft. If you know anything about the game technically, you probably know that the game operates on ticks, which happen 20 times per second. Now in theory, this means we could just put all the logic for Conway's Game of Life into the tick function of the blocks we want it to operate on. However, the truth ends up being a little more complicated than this. See, Minecraft doesn't update every block at exactly the same time, even if they're within the same tick, so the blocks end up overriding each other and we get undesired results. This happens when blocks look at their neighbors to determine what action to take, and then take that action, all while their neighbor might still be trying to figure out what action to take. We end up with a race condition, where depending on which block acts first, we get completely different results. Now the way Minecraft resolves this for most block ticks is by assigning them in order, which we can see here. Whenever a block updates, it sends an update to the adjacent blocks in this order. We can actually see this happening in-game. Notice that the pistons to the east and west of the redstone dust are activating, while the pistons to the north and south don't. We can also observe this for the other directions. Unfortunately for us, this is very different from the update order for Conway's Game of Life, where everything just happens simultaneously. Now, one way to fix this would be to completely rewrite Minecraft's tick update system, but that's a lot of work. Thankfully, there's an easy workaround. See, if instead of scheduling every tick to be an update tick, we schedule all odd ticks as data gathering ticks and all even ticks as update ticks, then every single block is going to update at the same time, and no matter what order they update in, it's not going to affect the results. By doing this, we get rid of the race condition by forcing all blocks to update at the same time and to gather information at the same time. From here, the implementation is fairly simple. Gather information on the odd phases and update the block on the even phases. For the sake of efficiency, we can also only update the dead cells if they're adjacent to a living cell. In the dead cell tick function, we do essentially the same thing. And that's it. This is Minecraft running Conway's Game of Life with nothing but tick logic and block updates. If you want to try and make something like this for yourself, let me know in the comments. There's a lot of directions this could be expanded. For example, you don't have to use farmland and grass blocks. You could even use TNT or air blocks. I'm interested to see what you guys come up with. If you enjoyed this video, please make sure to let me know in the comments. Videos like this take a long time to make, but they're very rewarding. If you want to see any other videos like this, let me know as well. Or if you have any other ideas for things you'd like covered, also let me know. Thank you so much for taking the time to watch this video. Have a good day.